All right, let's take a look at this problem. Product of array except self. Given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit 32-bit integer. You must write an algorithm that runs off n times without using the division operator. So, so we were asked to have an O of n time. I think I had somewhat like similar question to this, in which we were having of n times. Of course, now we have to store some values because otherwise you cannot calculate. You cannot calculate with O of n because in each element you have to have a constant time operation to calculate that index. So for that, let's take a look at this. So normally my first approach would be to multiply everything and divide it by this, but it says without a division operator. So because of that, we can instead of dividing to this, we can just have two arrays for every element, because so when we are dividing by 2, we are basically like multiplying everything, dividing to the current number so that we have the left and right side multiplied. So since we have left and right side multiplied, like in the solution, we can have a um, we can have a we can have two arrays that's holding different kinds of multiplications, maybe like a left to right, right to left, and we could, using those two lists, we can have all for n time without using division operation. So if we take a look at this example, 1 2 3 4, we would have like 1 2 6 and times 4 is 4, and also like 4 12 times 2 is 24, right? So here, if we multiply these, if you divide that to that, or that to that, so here the multiplication of this index is that times this. Maybe it's easier to, so for, let's see how can I calculate this. So I have 4 indexes. So in the first one, I'm holding the value, current value times that, divide that, but I'm not allowed to divide. So I have to multiply that and that. Maybe that 4 and 2. So if we align in such way that we can I have 1 after all that? After all that. if I have one, you don't need that. So when we are going from right to left, we don't include that, but we have to start from 1. When we are going left to right, we don't include the last. We don't need that. So it will be something like that. And we will, every time we will multiply these to get the result. And so for this, so we will have left, right will be that. Right, left will be that. So we'll have current is 1 for every I in range length of nums. We want to go from left to right, but here the first thing we want to do is to put current in left, right, and current, and then current is equal to we should, by the way, start with current is equal to times equal to nums I. So we multiply it by 1, and then here multiply by 2, multiply by 6, append it, and we have it 1, 2, 3, 4, right? And then also for the other part, we simply have to do the same thing. Let's say that this is current left, or I mean, I can just copy this. Maybe I can have it in a one for loop, but it's easier to understand this way, so I'm gonna just copy the code. As we see here, we're doing the same thing, and we will have this array, and then at the end, so do I have to return this result? Okay, so results, my result will be yeah, so I also need this start, and for every I in range length nums, for every element we simply want to calculate it by multiplying these two indexes of these two arrays, and for that we just do this, which is left, right, I times right, left, I, and now we just return the results. So let's see. Get it. By the way, if we this should be 1, 2, 3, 4. Let me print. Let's see. Is there a problem with this? But this cost at each time this costs. Now it should be okay. Okay, so this is of n time, this is of n time. Here I could do something like this. Curve, so curve right is equal to 1, curve left, I'm gonna have it in one thing. So curve left will be that, curve right will be that, equal to nums y. And actually, I'm gonna call this j. Here j is equal to nums minus I minus 1, and after that right, left, append append curve right, curve left. We append that here, multiply it by that number. Let's see. I have a syntax error. J is there. So this will be of n time, this will be of n time, this will be of n time. So at the end we will have of n, but with time complexity, I mean space complexity of n, because we have three arrays that are storing different things. So okay, let's see. All right, so anything else I want to add? Can we have something better than this? I don't think so, because we have to go through every element in the array, which is of n time, and we have to store some values in an array somehow. So it is. I think this is the best complexity we can get. So yeah, that's it.